Morning students, welcome to the first lesson on the next topic in applied mechanics, and that's simply supported beams. Simply supported means supported at 2 points along its length. Okay? If something is simply supported, whether it's a beam or a frame or a truss, if it's supported at 2 points along its length, it's simply supported. Okay, if a beam is supported like this, with that bit hanging over, which we call a cantilever, which I mentioned before, even though it's got a cantilever there, it's still simply supported. And even if it's cantilevering or hanging over at that end there, it's still simply supported. Okay, so if it's supported at 2 points along its length, we say it's simply supported. Okay, I don't want that there, I just want to take it away. Alright people, there's our first example. We have a beam, we show it as a line, and there's a pin joint there and a roller joint over there. Okay, and the pin joint, before we start, the pin joint has how many possible reactions? 2 possible reactions, and the roller joint has 1 possible reaction. And notice here, we've got only loads acting vertically, so therefore we're only going to have vertical reactions. And I'm going to draw it in, because I'm assuming it's going to be over there. I'm going to call it VA, and I'm going to call that VB. So the question is there to determine VA and VB. Okay, and I'm going to find the reactions at VA and VB using the principle of moments, which we've done so much of in the previous lessons. I can start by any one, so I'm going to say the sum of the moments about A is equal to 0. Why are the sum of the moments equal to 0? It's because this whole system here is in equilibrium. Alright, and we know that clockwise moments are positive, anti-clockwise moments are negative. Okay, clockwise positive, anti-clockwise negative. Right, I'm taking moments about A. We have a hinge here. There's a hinge over there. So this beam is free to rotate about A, but it can't move left or right, and it can't move up and down, but it can rotate. Okay, so can you see that about this point A, we can have the 10 kilonewton force, the 12 kilonewton force, the 16 kilonewton force, wanting to tend to turn the beam clockwise about point A, so they're all going to be positive, and VB is going to want to tend to turn the beam anti-clockwise with respect to A, so it's going to be negative. You can take them in any order. I'm going to take the pluses first as usual. Right, and notice there, all the forces, the distance from there to there is the lever arm for that force, and that distance is at right angles to the point of rotation. So it's simply going to be the force multiplied by the distance. Right, 10 times 1 plus 12 times 2. Okay, because 12 is acting there, and the lever arm is the distance from where the force is applied to the point of rotation, so it's times 2 plus 16 times the distance all the way to there, which is 4, minus VB. Why is VB minus? Because it's turning anti-clockwise with respect to A, and the distance from B to A is 2, 4, it is 6. There's no more, so it's equal to 0. We have one equation with one unknown, therefore we can solve for VB. So therefore VB is equal to the calculator. So it's 10 plus 24 plus 64 is equal to divided by 6. 16.33. I just spotted an error here. That should be times. Let me just change that. It should be times. Okay. That should be times. My apologies. Times. There we go. Okay. I've worked out VB, and VB I get equal to 16.33 kilonewtons. Let me just check my answer again. It is 10 plus 24 plus 64 divided by 6 I get 16.33 kilonewtons. And because the answer is positive, it means that our assumption that VB is acting upwards is in fact correct, like we done in the previous occasions. Okay. Right. Notice again, I took moments about A to find VB. Now I'm going to take moments about B to find VA. So I'm going to say the sum of the moments about B is equal to 0. Right. VA is positive about B, and all the forces on the beam are anti-clockwise about B, so they'll be negative. You can take them in any order. I'm starting with the pluses first. Doesn't matter, I'm starting with VA first. So VA times, how far is VA from B? It is still 6 meters. Minus 10 times 2 times 5, minus 10 times 5, minus 12 times 4, minus 12 times 4, minus 16 times 2, 16 times 2, there's no more, so it's equal to 0. We've got one equation with one unknown, therefore we can solve for VA, and VA is equal to 50 plus 48 plus 32 is equal to divide by 6, and I get 21.67. Don't write my answers as it is there. Check that you get it. You can stop the video and you can check it out. 21.67 kilonewtons. Please write in units of measurement. It's not a moment, it's a force. If you leave the units out, I take one mark there, and that will be minus 2 if you leave it out. Some of you just love to leave it out. Put it in, otherwise you lose marks. And because the answer is positive, it means that our assumption that VA is going upwards is in fact correct. So VA, 21.67, VB is 16.33. Now people, now how do we know that these two reactions are correct? We're going to check them the first few times. Okay? I'm gonna write the check down. How do we check them? And by using another method, I'm gonna sum vertical forces. So I'm gonna say the sum of the forces in the vertical is equal to 0. Why is it equal to 0? Because our system is in equilibrium. Right, so it's plus VA, which is 21.67, plus VB, which is 16.33, minus 10, minus 12, minus 16. Right, do the calculation. 21.67 plus 16.33 minus 10 minus 12 minus 16 is equal to 0.00 exactly. Okay. The sum of the forces in the vertical is equal to 0. I did that. It is equal to 0. So therefore, VB is correct and VA is correct. Okay. Another way to put it is the sum of the downwards is equal to the sum of the upwards. Okay. Right, people? That's our first lesson in finding support reaction for a semi-supported beam. And I will see you in the next lesson.